Good morning, class. Welcome to our lesson. Today we're looking at probability statements. Okay, so probability statements, what are they? They are just telling us how likely it is for an event to occur, for an event to happen. Okay, so really what we're looking at is chance. What's the chance that we're going to have a favorable outcome or a favorable event? So let's look at a few different examples. Okay, flipping a coin. So how many choices are there when you flip a coin? There are two choices. Okay, there's two sides to the coin. You can have a choice of getting the head, okay, the queen's face, or a choice of tails, which on a nickel is the beaver tail. Okay, so heads or tails. Probability is expressed as the following. The probability of an event is the possible number of favorable outcomes as a fraction over the number of total outcomes, or all outcomes. So looking at our coins, what is the probability of heads? The probability of a head is there's one favorable outcome. There's one head on the coin. And what's the probability of getting an outcome? Two. There's two possible outcomes. So the probability is 1/2. So you would say the probability of heads is 1/2. Okay. Now, if you want to go into a decimal, you could say it's 0.5, it's 1/2. But for most of us, we're just going to leave it right here as a fraction. You could then, of course, if you wanted to, times this by 100, and that would equal 50%. So you can express it as a fraction or as a percent. Usually we don't actually leave it as a decimal, okay? But you can, because you got to go from fraction to the decimal. To go to the decimal, we go 1 divided by 2, and that would give us the 0.5. And then we times by 100 to get to percent. Okay. Remember, percent stands for per 100. So we can say to get heads, it's 50%. Tails, same thing. There's one tails on the coin. So we would say one possible favorable outcome and two possible outcomes overall. So again, the probability of tails equals 1/2, which equals 0.5 as the decimal as we go 1 divided by 2, and times that by 100 to get you percentage, that equals 50%. What's the total possible outcomes? Well, 50 plus 50, 100% of either getting heads or tails. So remember that this is just a prediction, okay? It doesn't tell us what will happen next, all right? Every time we flip the coin, you will get heads or tails, all right? And this is complete. Okay, so we're going to do this. We're going to toss 50 coins, see what happens with our heads and tails. Now, I actually have this online coin flipper I'm going to show you, but to get 50 tosses, I don't want to press this stupid thing 50 times. So what I have is I got 10 coins, 5 up here, 5 down below. So what I'll do with these 10 is I'll just flip all of them 5 times. So I'll get 50 flips in. So here we go, we flipped it. And so we have tails, 1, 2, 3, 4. We have 4 tails. So I'm going to fill that into my chart. 4 tails. And then for the heads, there will be then 6. Okay. So I'll go back and I'll flip it again. So that's once. Flip it again. And then we got heads. We have 1 heads, 2 heads, 3, 4, 5, 6. So now we have 6 heads. So we'll go plus 6. And then this would be 4 because there's only 10 coins. So they got to add up to 10. We'll go back. We'll flip again. And so now we have 1, 2, 3, 4, 5, 6, 7 tails. So I'll fill that in. We have 7 tails, and then that means there has to be 3 heads to make it 10. So I'll go flip it again, flip again. And so now I have 1, 2, 3, 4, 5. 5 tails, so it'll be 5 and 5. And I'm going to do this one more time. So I'll flip again. And now I have here 1, 2, 3 tails. So I'll then go and flip again. Sorry, plus 3. And then this will be, whoops, other way around, my bad, plus 3, plus 7. So altogether then, looking at my totals, I got 6 plus 6 is 12, plus 3 is 15, plus 5 is 20, so I have 27 heads. Over here, I got 4 plus 4 is 8. 8 plus 7 is 15, plus 5 is 20, plus 3 is 23. Okay, so when I perform 50 tosses, guess what? I am close to 50% each. So my question, of course, I'm sure you have this, is why is it not exact? Why is it not exact? Well, the reason why is because it's only a prediction, okay? So probability is only a prediction. It's not actual fact that that is going to happen. Probability, okay? So looking here, probability, close to 50% each, because probability is only prediction. Now, the more times we flip the coins, the more accurate we're going to be. So if we go to 100 tosses, guess what? It's going to be closer to 50%. So if we do 100 tosses, heads might catch up and it might pass, but it might be something like 52 and 48. If we did something like maybe 200 tosses, then eventually what we're going to find is it might be something like 101 and 99. It's not going to be exact, but it's going to get closer and closer to exact. And if we're doing more, it's going to be even closer. Okay, so probability, it's just a prediction. Next, probability for deck of cards. So a deck of cards has 52 red cards. If half are red, half are black. So for red, half of 52, excuse me, is 26. For black, half of 52 then is the other 26. Okay. What about things like there's 4 suits. Okay. There's 4 suits on a deck of cards. The suits are hearts, which are red. And then how many hearts are there? Well, there is actually 13. Then there are, what's the other one? Diamonds. Those are also red. And the diamonds equals 13. What about the other suit? The other suits are spades. That would be a black suit, so usually they are a black color. I want to use blue just so that you can see it easier. That would be 13. And then the other one would be clubs, and that will also be a black suit. So the numbers will be black on the cards, and that's going to equal 13 as well. Okay. So what about something like the aces? So for the aces, you would have 4. There'd be 1 of each suit. Okay. And so sometimes we talk about face cards. Okay, so aces, 4, 1 of each suit. So you'd have 1 ace of hearts, ace of diamonds, ace of spades, ace of clubs. Okay. Face cards. So face cards, they have a face on it. So your face cards are your jacks, your face cards are your queens, and your face cards are your kings. Those cards all have a face on it, and so those are the face cards. Those are the cards you call face cards. Okay, so let's get into probability. What is the probability of a spade? So probability of a spade is going to equal what? Well, it equals 13 spades in the deck over what? Well, over all the cards, which is 52. Okay, then what we should do is we should put them into lowest terms. So ideally, you go into lowest terms. And so with this one, you would try and divide by 13 if you can. So I divide this one by 13, which would equal 1. And I divide this one by 13. Let's try it in the calculator. You can always guess and check. 52 divided by 13 equals 4. So then this would equal 1/4. Okay? So this would equal 0.25, which equals 25%. So what we would say is the probability is 1/4 or 25%. Those are the two ones that we'd work with. All right, let's go try the next one. What's the probability of a 4? So probability of a 4, how many 4s are there in the deck? There are 4 4s. And then we would say, well, how many cards are in the deck? Well, there's a total of 52 different probabilities. So 4 over 52. What is that in lowest terms? Well, try and divide by 4. I don't know, maybe we can, maybe we can't. So we divide the top by 4, which we know works. That would be a 1. Divide this one by 4. Let's go to the calculator. 52 divided by 4 equals 13. So it's 1 over 13. What is that as a decimal? I really don't know. I will try. 1 divided by 13. Whoops, I think I messed something up there. 1 divided by 13. Big long number. So because it's big and nasty, I'm just going to not change into percent. Otherwise, that'd be like 7.7%. So I'm just going to leave that one as 1 over 13 because it's not nice and pretty. What's the probability of a red card? Well, how many reds are there in a deck? Total of 26 reds in a deck out of 52 possible cards. Lowest terms, divide by 26. It's going to be 1/2, which is 50%. There you go. Okay, so the probability of red card is 50%, 1/2. And how do I get 50%? I go 1 divided by 2, and then I would times by 100, and so I get 50%. Okay, so the answers we would talk about, we would say 1/2 or we'd say 50%. Both of those are perfect. Probability of face card, I'm not going to tell you. You got to try and figure this one out. Okay, so how many face cards are in a deck? Well, guess what? I'll help you out. I'll give you a hint. There's 4 of each faces. So you're going to have to do a little bit of figuring to figure that out. But remember, 52 cards in a deck. Okay? What about the probability of a 2 or a 4? Well, there are 4 2s in the deck and there are 4 4s in the deck. So for this one, the probability would be 8 over 52. Okay? So that you can go and figure out what that would be in lowest terms, etc., etc. Let's look at the next one, rolling a dice. So when you're rolling a dice, you have the numbers 1, 2, 3, 4, 5, 6. There are 6 outcomes possible. Okay. So when you're doing these, there are 6 outcomes possible. So probability of rolling of 6? Well, probability of a 6, there is 1 6 on the dice. There's 6 possible outcomes, so it's 1 over 6. What about probability of 7? Well, how many 7s are on the dice? You're right, 0. So the probability of a dice would be 0 of 6 possible outcomes. This one we can simplify. There is no probability, it is 0. Okay? Good. Next ones you guys can do on your own. Probability of a number less than 7. Well, how many numbers are less than 7 on a dice? Less than 7. Well, there is 6 out of 6, so it would be 100%. Okay. Probability of 2 or 4, you guys can work through that one. Here's a bag of marbles, so you're going to have to count, okay? So you complete these ones, and I'll post the answers up, all right? So I want you to complete and check your answers in 10 minutes, okay? I'll have the key is in the lesson. So you can go and check the key. Okay, there we go. Happy work, happy math.